But so then something else is so this is a game of life in an IDA comment. And the way this is just working is I just wrote a quick game of life board, and then I just push the frames to a comment, and then sort of goes on. So then I also had a pre-prepared board for something cooler. So I set up a glider gun, so you can sort of get some glider gun action going on. And then I had a few other demos. Oh, this is never gonna end. So I did this. Okay. So one thing I actually did that was really handy and was a good use of IDA-rub and actually did involve reverse engineering is if you look at any OSX binaries, for example, I will take ls. Do I still have it open? Yes. So if you look at the way they do this, all OSX binaries are compiled with fpic, so all of the code is position independent. So if you see this call instruction right here, all it does is it takes the value of the next instruction and puts it into EBX, and then all of these addresses are relative to EBX. So basically, all of the data accesses are relative to the current function. So it just basically gets EIP and then addresses everything relative to that. So IDA knows any of the references from these because they're all. I mean, IDA doesn't understand the code, so it doesn't know what's going on. So all of these addresses are completely useless because they're just relative to EBX and we don't know anything about it. So I wrote this little script and also demonstrate the local mode then. So if I run the plugin again after it's already running, it just gives you the option to stop it. So I'll stop it. So then I wrote this little thing, reverse engineering parallels. Yeah. So I just wrote this little code that walks through, and it will find all of these get EIPs and then calculate all of the addresses and then fix up all of the references for you. So if I run this, I can select, instead of starting a server, I can select to load a file. And then I can pick this convert offsets. So then what it does is I just name this function fredder EBX, and it knows how to find it. So then I click OK, and it finds all these functions that called this thunk, and then it will update all of the EBX relative addressing to actually be the absolute address. And then you can see we actually have all of the names and addresses. So this is like mock-init routine, this was the environment pointer, and this was argv and argc, stuff like that. So, and it did it for the whole database. So you can see all of these places are fixed up. Let me find some other examples of it. But and that was pretty simple to do because, I mean, it wouldn't have been a hard thing to do in C++ either, but I mean, it's a really simple script, and it's nice just to be able to do that sort of stuff while you're working on a project. So I'll close this. And then another thing is I was doing some OSX stuff, and for Objective-C binaries, I don't have a copy of this. I wish I did. But you basically, the disassembly is really rough because, well, number one, this is PPC, so you have, it's a bit different. And all the Objective-C calls are done at runtime, and so there's not really any information. So I wrote an IDA-rub script that will just go through an Objective-C binary, and it will, all of these names were generated by the script. So like message share instance, class reference preferences, message set serial number. So yeah, that's another thing that was really useful and really easy to do. I just sort of, walk through, and then you can set all of these names to actually what the values are and stuff. So if you do any OSX reverse engineering, this is really helpful. Yeah. Blah, blah, blah. So I think that was pretty much all I've had for the demos. It's not that exciting because it's basically stuff you could do in IDA from the beginning. It's just making it easier to do. So it just allows you to write simpler scripts and stuff like that to sort of hack stuff up. But so I have 10 minutes left for questions if anybody has any. Yeah.
Why do you use Python?
Yeah, I know. I'm trying to think there's actually a good reason not to. Well, some of the RPC stuff I wouldn't actually know how to do in Python, but I imagine that you could do the same sort of stuff. Someone talked about maybe trying to do the network dispatching stuff in IDA Python, but I haven't seen anything about it. But any real questions? Anybody want to see those again? More games of life? Each board's unique. Hours of fun. All right. All right, well, that's it then. Thanks.